classification. The shift of perspective to generative grammar within the biolinguistic framework opened the way to much more far-reaching inquiry into language itself and language-related topics. And it also greatly enriched the variety of evidence that bears on the study of each individual language. So it can include essentially anything: acquisition, use, neuroscience, associations, much else. And it can also include what has been learned from the study of other languages. That's on the quite well-confirmed assumption that the capacity for language relies on shared biological properties. That's the topic of what in the last 50 years has been called universal grammar, UG. It's adapting a traditional term to a different framework, different concept. In earlier years, it was understandable that the question, what is language, received only such indefinite answers as the ones I've mentioned, all of them, notice, ignoring the basic property. It's, however, I think, surprising to find that similar answers remain current in contemporary cognitive science. One typical example, current study on evolution of language in the journal Frontiers of Psychology, characterizes language only as the full suite of abilities to map sound to meaning. It's basically a reiteration of Aristotle's dictum. It's much too empty to ground further inquiry. Again, no biologist would study evolution of the visual system, paraphrasing, assuming no more about the phenotype, that it provides the full suite of abilities to map stimuli to percepts. Couldn't get anywhere with that. And you couldn't publish a paper on it either. The editors in the audience might take that to heart. There are also broader reasons to be concerned with the question, what is language? There's a rather clear indication of these given in a recent book by one of the leading scientists who studies human evolution in Tattersall. There's a recent review of the currently available scientific evidence. He observes, quote him now, "It was once believed that the evolutionary record would yield early harbingers of our later selves. The reality, however, is otherwise, for it's becoming increasingly clear that the acquisition of the uniquely modern human sensibility was instead an abrupt and recent event, which he dates in the very narrow window of roughly 50 to 100,000 years ago. From an evolutionary point of view, that's a flick of an eye." And to quote, "The expression of this new sensibility was almost certainly crucially abetted by the invention of what is perhaps the single most remarkable thing about our modern selves, language. And therefore an answer to the question, what is language, matters very greatly to anyone concerned with understanding our modern selves, what kind of creatures we are." The founders of modern biology, of course, lacked the evidence of current science, but they adopted a general view that's not too different. So Darwin, for example, wrote that man differs from animals solely in his almost infinitely larger power of associating the most diversified sound and ideas. Modern terms, that means in having a generative grammar. Phrase almost infinite is a traditional phrase that we have to interpret today as actually infinite, has no meaning. Makes no sense to contemplate a huge, non-extendable list. That's meaningless. Much earlier, at the origins of modern science, Galileo was entranced by what he called that marvelous invention, referring to the alphabet, that provides the means to construct from 25 or 30 sounds that infinity of expressions that enable us to reveal everything that we think and all the movements of our soul. It's audible thought in Whitney's phrase, although Galileo went far beyond Whitney in that he recognized the unbounded character of the language. It's kind of an obvious point, but it's very hard to find anyone who noticed it in the 2,500 years of serious investigation of language. The same recognition and a much deeper concern for kind of the creative character of the normal use of language. Shortly after, a little after Galileo, that was to become a core element of Cartesian science, what's nowadays called philosophy, same thing as science in those days. There's no reason today to doubt the fundamental insight of Descartes that use of language, normal use of language, is indeed a creative activity. It is typically innovative without bounds, so in principle infinite. It's appropriate to circumstances, but not caused by circumstances. It's a crucial distinction. And it can engender thoughts in others that they recognize they could have expressed themselves. That's normal use. And the observation appears to be correct as far as we know. There is an aphorism of Wilhelm von Humboldt that's commonly quoted, pointing out that language involves infinite use of finite means. But it's worth bearing in mind that he's talking about use. It's infinite use of finite means. More fully, he described the unending and truly boundless domain of language as the essence of all that can be thought. That places him in the tradition of Galileo and others who associated language closely with thought. He actually went beyond to assert the identity of language and thought, a much stronger claim, while recognizing that, still quoting, language must make infinite employment of finite means in confronting its boundless domain. There has been great progress in understanding the finite means that make possible infinite use, but the infinite use itself remains pretty much a mystery, despite significant progress in some particular areas, like understanding some of the conventions that guide appropriate use. But the basic problem remains as mysterious as it was for Descartes and Cartesian. A century ago, another great linguist, Otto Jespersen, raised the question of how the elements of language come into existence in the mind of the speaker on the basis of finite experience. Another mystery, yielding, he said, a notion of structure that's definite enough to guide him in framing sentences of his own, crucially free expressions, typically new to speaker and hearer, over an unbounded range, hence infinite range. And then the task of the linguist, which he said, is to discover these mechanisms and how they arise in the mind, and to gain, quoting him, a deeper insight into the innermost nature of human language and of human thought. Those ideas sound much less strange today than they did during the structuralist, the behavioral science era that came to dominate much of the field, marginalizing Jespersen's insights. So, for example, when I was a student in the late 1940s, nobody ever heard of him. I found his work when wandering around the Harvard Library. While reformulating Jespersen's program, the basic task is to investigate the true nature of the interfaces and the generative procedures that relate them to determine how they arise in the mind and how they're used, with the primary focus of concern naturally being free expressions, typically innovative, creative behavior. As soon as the earliest attempts were made, roughly 60 years ago, to deal with these questions, to construct explicit generative grammars, many puzzling phenomena were discovered, which hadn't been noticed, although they're kind of obvious when you think about them. They hadn't been noticed as long as the basic property was not clearly formulated and address, and syntax was just considered use of words, often use of words following a sequence of thoughts. Diderot famously argued that French would be the language of science, and German and English would be the language of poetry, because in French the words follow exactly the order of thoughts, whereas in the other languages it's kind of mixed up a bit, so it's better for fancy, and you can determine how well that follows. All of this is somewhat reminiscent of the earliest stages of modern science, early 17th century. So for millennia, the scientists had been satisfied with very simple explanations for quite familiar phenomena. So rocks fall, steam rises, because they're seeking their natural place. Objects interact because of what were called sympathies and antipathies, which bring them together, push them apart. We perceive a triangle because the shape of the triangle literally flits through the air and imprints itself on our brain, and so on. Lots of simple explanations. When Galileo and others allowed themselves to be puzzled about these facts, modern science began. And it was quickly discovered that our beliefs are mostly senseless and that our intuitions are all wrong. And it's worth remembering that the willingness to be puzzled is a very valuable trait to cultivate. And it's from early education to the most advanced inquiry. One puzzle about language that came to light 60 years ago and remains alive, and I think is highly significant in its import, it has to do with a very simple but curious fact that we ought to find puzzling. So take, say, the sentence, instinctively, eagles that fly swim. The adverb instinctively is associated with a verb, but it's associated with swim, not fly. Similarly, if you ask the question, can eagles that fly swim? That's about ability to swim, not ability to fly. There is a thought that the sentence fails to express, and it's quite difficult to formulate without circumlocution, as you can determine by trying. That impedes communication, one of many such cases. What's puzzling is that the association of the clause initial element, instinctively or can, to the verb is remote and based on structural properties, not proximate and based on linear properties. It's a far simpler computational operation, but never used. The language makes use of a property of a minimal structural distance, never uses the much simpler property of minimal linear distance. And the puzzle is why this should be so, and not just for English, but for every language, not just for these constructions, but for every relevant construction. And children acquire it. They never make mistakes about it. They acquire it reflexively, even if they have no data or very limited data. There is a very simple and plausible explanation for the fact that a child reflexively knows the right answer in these cases, even though evidence is slim or in fact non-existent often. The explanation is that linear order is simply not available to the language learner. It's one of those great principles that Jespersen was talking about. It's not available to the learner, to the child, so it never picks it. The child is guided by a principle of universal grammar that restricts search to minimal structural distance, the more complex notion. I guess the only explanation I know. There's no other explanation that's ever been proposed. Many have been suggested, but they obviously don't work. This principle of minimal distance is quite extensively employed in design of language and nature of language. There's presumably one case of a much more general principle that enters into that enters also into design and acquisition of language in other forms, not restricted to language, may actually be a law of nature, and call it minimal computation. And the evidence shows overwhelmingly, in fact, without exception, that invariably languages use the property of minimal structural rather than linear distance every relevant case, even though, again, the one that's not used is computationally far simpler. There's actually some supporting evidence in this case from neuroscience. There's a research group in Milan, Andrea Moro, who many of you know is the linguist in the group. They studied brain activity of subjects who were presented with two types of stimuli. These are invented systems conforming to UG and others not conforming to UG. So in the latter case, for example, an invented language that puts the negative particle after the third word of a sentence in order to negate it. That's a rule which is far simpler than the one that's computationally than the one used in every language that's known. What they found is that in the cases of conformity to UG, the language areas, normal language areas of the brain are activated, not other parts. But when linear order is used, like in that rule for negation I suggested, that they suggested, I repeated, when the linear order is used, there's kind of diffuse activation in the brain, suggesting that the people are treating it as a kind of a puzzle and not as language. And there's other work by Neil Smith and Yancy Maria simply with a cognitively impaired but linguistically fluent subject who they've worked with, and they reach pretty much the same conclusion. Actually, there is a small industry in computational cognitive science that's attempted to show that these properties of language can be acquired by statistical analysis of massive data. Actually, that's not the only topic that's been investigated beyond superficiality. Every attempt that's clear enough to be investigated has been shown to fail irremediably, but it really doesn't matter because the efforts are beside the point in the first place. Suppose they work, which is virtually impossible. That would still leave untouched the only serious question. Why does language invariably use the complex computational property of minimal structural distance while never employing or even entertaining the far simpler option of minimal linear distance? That industry is a good illustration of the unwillingness to be puzzled that I mentioned earlier. And again, the willingness to be puzzled is the first step in serious scientific inquiry, as has been recognized in the hard sciences since Galileo. A broader thesis is that linear order is never available for computation in the core parts of language that involve syntax and semantics. Of course, there is linear order, but the thesis would be that it's a peripheral part of language, kind of tacked on. It's a reflex of properties of the sensory motor system. The sensory motor system doesn't allow us to speak in parallel or to produce structures. We have to get it through the sensory motor system, we have to put things in a linear order. So the order could just be a reflex of the fact that whatever's going on in the mind has to pass through this filter to get externalized, but has nothing special to do with language. And the sensory motor system itself is not specially adapted for language, except maybe in peripheral aspects. The parts that are essential for externalization and also perception appear to have been in place hundreds of thousands or millions of years before language emerged. They're just kind of there. Well, the matter's not settled. This is one of the topics that is open, but I think there's quite substantial evidence to show that the broader thesis may in fact be correct. So if that's true, as I suspect it is, then the basic property has to be reformulated. Not the way it's been in recent literature, including papers of my own. Rather, the basic property would be generation of an unbounded array of hierarchically structured expressions, mapping to the CI, the conceptual intentional interface, basically the system of thought. Well, if that turns out to be true, as I think evidence is pointing us to, then there's good reason to return to a traditional conception of language as an instrument of thought and to revise the common sense dictum accordingly. Language is not sound with meaning, but meaning with sound. More generally, some form of externalization, typically sound, but appears to be modality independent. In fact, externalization is rarely even used. And by far the most use of language never is externalized. It's called internal dialogue or inner speech. That's 99.9% of your use of language. It's virtually impossible to, it takes a tremendous active will not to talk to yourself when you're awake, when you're asleep, walking down the street, whatever it may be. It's just going on all the time. Now, there isn't much research on this topic, unfortunately. There's some, it goes back to Chomsky. There's been little research. And it conforms to what introspection suggests, my introspection at least, you can try yours. What reaches consciousness, I think, is just small fragments. And then fully formed expressions can be instantly produced internally, usually aren't, and produced far too quickly for articulators to be involved or even instructions to articulators. And they're often not produced, even internally. It's quite an interesting topic, which, as I say, has been barely explored, could be subjected to inquiry. And the reason it's not explored is that there's kind of a prejudice against studying mental actions that don't reach consciousness, which is probably what almost everything is. But a lot of dogmas about how you shouldn't study that. You should, actually. Well, putting aside this issue and just looking at what we know about the way language is designed and constructed, like the examples I gave, that gives good reason to take seriously the intuitions of Galileo, many others, that language is essentially an instrument of thought. It would then follow that externalization is an ancillary process, not just a reflexive properties of the sensory motor system, which have nothing special to do with language. And there is further investigation that I think supports this conclusion. Now, if it's established, a lot of things follow. One thing that follows is the particular uses of language that depend on externalization, among them communication, which is one, not the only one, are even more peripheral aspects of language. Now, that's contrary to virtual dogma in these various fields, dogma that, however, has no serious support. It would also follow that much of the extensive speculation about language evolution, language origins, is just on the wrong track to begin with. Because if you look at it, most of it is about speculations about evolution of communication, which is looks like some peripheral aspect of language. Well, this matter has not been studied, but I suspect that the modern doctrine, I think dogma, that holds that communication is somehow the essential function of language, I suspect that derives from the influence of associationist and behaviorist assumptions, which retain quite a strong grip, even among those who reject them, along with highly oversimplified and quite untenable interpretations of modern evolutionary theory, evolutionary biology. That's an interesting question. I'll put it aside here. Well, let's return to the basic property, the now reformulated. The computational system of I language yields an unbounded array of hierarchically structured expressions, mapping to the system of thought, the conceptual intentional interface, all, of course, unconscious and inaccessible to consciousness. There are then ancillary processes which may or may not externalize these internal objects in some sensory modality, and there are analogous observations about perception. Naturally, we seek the simplest property, the simplest theory of the basic property, the theory with the fewest arbitrary stipulations. Each stipulation is, of course, a barrier to some eventual account, if attainable, of the origin of language. And I stress eventual, I think we're very far from it. That's standard scientific method, so nothing to say about it. But we can ask how far this resort to elementary scientific method will take us. Well, so we asked, look into the nature of computational operations. There is a simple computational operation which is embedded in some manner in every relevant computational procedure. It's an operation that takes two objects, call them X and Y, that have already been formed, and constructs a new object, call it Z, called emerge. So it's called Y. It is modified in the course of the operation merge. It also follows that they're unordered, because that would be a further complication. And that's a conclusion that's quite plausible for language on other grounds, and I've indicated. That means that merge of XY, that just gives the set containing X and Y. That does not mean, of course, that the brain contains sets, as some current misinterpretations claim and dispute. But what it means is that whatever's going on in the brain, about which we know very little, has properties that can properly be characterized in these terms. Just as we don't expect to find the Kekulé diagram for benzene in a test tube. Understood in the science, there's a lot of confusion about it in linguistics. Well, suppose X and Y are merged, and neither is part of the other. So that's, say, combining read and that book to form the syntactic object that corresponds to read that book. Name for that is external merge, two things separate from one another. Suppose that one of them is a part of the other, say Y is part of X. So as in combining which book and John read which book, taking which book contained in John read which book, you merge it, you get which book John read which book. Now that surfaces as which book did John read by further operations that I'll come back to. That's an example of a ubiquitous property of language, ubiquitous phenomenon called displacement. Phrases are heard in one place, but they're interpreted both there and somewhere else. And the sentence in this case is understood as, for which book X John read the book X. That's interpreting which book John read which book. Okay? That goes straight to the thought system. It comes out the right way. Well, in this case, the result of merge of X and Y is again the set containing X and Y, but now it has two copies of Y. So one of them is the original one remaining in place, and the other is the copy that's merged with the whole thing. Now that's called internal merge, sometimes called the copy theory of movement, but it's the minimal theory, the optimal theory comes for free. External and internal merge are the only two possible cases of binary merge, to get evidence that these operations are binary. And it's important to bear in mind that both of them come free. It would be a complication if you had only one and not the other, whichever way it went. It would require a stipulation of some kind, to bar one of them because they're free. And that's an important fact. Its importance has gradually sunk in since it was noticed about 15 years ago. For many years it was assumed, by me as well, that displacement, this ubiquitous phenomenon, is a kind of an imperfection of language, kind of a strange fact that has to be explained away by some more complex devices, complex assumptions about universal grammar. But that turns out to be incorrect. Displacement is what you should expect on the simplest assumptions with no stipulations, just everything works perfectly. Language forms, kind of like the way a snowflake does, just the simplest possible way. It would be an imperfection if one displacement were lacking. That's significant. And another important fact is that internal merge in its simplest form, satisfying the overarching principle of minimal computation, it yields the structure that's appropriate for semantic interpretation. It's just illustrated in the simple case of which book did John read. This right form for semantic interpretation is which book John read which book, because right for the thought system gets interpreted the right way. However, these are, of course, the wrong structures for the sensory motor system. Universally in language, only the structurally more prominent copy is pronounced, as in the case I mentioned, the lower copy is deleted. There actually is a revealing class of exceptions which in fact support the general thesis, but I'll put that aside. Why deletion of copies? Well, that follows from another application of the overarching principle of minimal computation, namely compute internally and articulate as little as possible. That's obvious principle of minimal computation. And there's a result. The result is that the articulated sentences have gaps. And so the same is true for inner speech, that you call yourself has gaps. That's tricky because the hearer has to figure out where the missing element is. It's well known in the study of perception and parsing that yields quite difficult problems of interpretation. Filler gap problems are called one of the hardest problems for writing a parsing for program, similarly for perception. In this very broad class of cases, something interesting has happened. The design of language, the basic structure of language, is favoring minimal computation, and it's disregarding the complication in the use of language. That's significant too. But notice also that if some theory comes along, there are many of them, that replace internal merge by some other mechanism, that theory has a double burden of proof to bear. The first part is to explain why it has the stipulation barring internal merge, which otherwise comes free. And secondly, it has to justify whatever new devices are formulated to yield displacement. In fact, displacement with copies, notice, which is generally the right form for semantic interpretation. Strain your imagination a little by giving one more complex case, not too complex, I hope. But so take the sentence. Which of his pictures did they persuade the museum that every painter likes best? Okay, that's derived by internal merge from the underlying structure. Which of his pictures did they persuade the museum that every painter likes which of his pictures best? It's derived by deletion of copies from that. Now that one is formed directly by internal merge with displacement and two copies. So same as which book did John read which book? In this case, which of his pictures did they persuade the museum that every painter likes which of his pictures best? The phrase which of his pictures is understood to be the object of likes, where the gap is in pronunciation. It's quite analogous to one of his pictures. They persuaded the museum that every painter likes one of his pictures best. Same interpretation, even if there's a gap. And that's just what the underlying structure of two copies provides. And that has further consequences. There's a quantifier variable relationship between every and his, and that carries over. So which of his pictures, suppose you say, which of his pictures did they persuade the museum that every painter likes best? The answer can be his first one. That's different for every painter. It's exactly the same as one of the interpretations of they persuaded the museum that every painter likes one of his pictures best. Now, in contrast, no such answer is possible for the structurally similar expression of which of his pictures persuaded the museum that every painter likes flowers. Structurally the same, but you don't get the quantifier variable interpretation. In that case, his pictures doesn't fall within the scope of every painter. Well, evidently, it's the unpronounced copy that provides the structure that's required for quantifier variable binding. And the results follow directly from the simplest form of merge, internal merge, and copy deletion, also required by minimal computation, that very much is in the simpler case that I mentioned. And if you go on, there are many much more intricate cases. Well, in all of these cases, just like instinctively eagles that fly swim, it's inconceivable that some form of data processing yields these outcomes. There's no point in trying, no conceivable way that could be. Relevant data simply are not available to the language learner. The results must therefore derive from what David Hume called the original hand of nature. In our terms, that means genetic endowment, specifically UG, universal grammar. And in ways like this, we can derive quite far-reaching and quite firm conclusions about the nature of UG, solving some strange puzzles. Well, there are many claims in the literature that there are no genuine linguistic universals, and no UG linguists above among you are familiar with this. However, the reference is, if it's not just confusion, the reference is presumably not to UG, to universal grammar, but rather to descriptive generalizations, Joseph Greenberg's famous universals, for example. But generalizations are quite likely to have exceptions. That's the nature of generalizations. And these are very valuable as a stimulus to inquiry. Exceptions to deletions of copies, for example, which I mentioned, and in fact reinforce the main principle when you look at them closely. That's quite standard in the sciences. So take one famous case, discovery of perturbations in the orbit of Uranus did not lead to the abandonment of Newton's principles and Kepler's laws, or to the broader conclusion that there are no physical laws. Kind of thing that happens in linguistics and cognitive science, but in the sciences it didn't lead to that. And what it led to was inquiry, postulation, later discovery of another planet, Neptune. It turned out everything worked. Exceptions to largely valid generalizations play a similar role quite generally in the sciences and have done so repeatedly in the study of language. Another point to bear in mind. But what we conclude, I think, is that if language is optimally designed, it will provide structures which are appropriate for semantic interpretation, but that yield difficulties for perception, hence for communication. There are many other examples that lead to the same conclusion. So structural ambiguities, garden path sentences. One case of particular interest is what's called islands, as illustrated, so-called ECP constructions, sentences constructed from the underlying expression. They asked if the mechanics fixed the cars. You can ask how many cars, you can ask how many mechanics. That gives respectively how many cars did they ask if the mechanics fixed, how many mechanics did they ask if fixed the cars. They're quite different in status. how many mechanics did they ask if fix the cars is a perfectly fine thought, but you can't say it that way. You have to say it with some circumlocution, impeding communication. And there are plenty of similar cases. A lot of them aren't understood, but to the extent that they're understood, invariably, I think, the examples, the structures result from free functioning of the simplest possible rules, yielding difficulties for perception, hence communication. Where there are, if you look hard, you can find quite a few conflicts between communicative efficiency and computational efficiency, like the kind I just illustrated. And in every known case, communicative efficiency is sacrificed. It's never considered. Go for computational efficiency, meaning, again, that language looks as if it's designed the way a snowflake is. That's just the way the principles of nature work. And if it impedes communication, too bad, as it often does. Well, that lends further support to the revision of the common sense Aristotelian dictum, and support for the view of language as an instrument of thought, with communication and other uses being ancillary properties, kind of tacked on, nothing special to say about language. And I think that conclusion fits very well with the very limited evidence that we have about the emergence of language. Apparently quite suddenly in the evolutionary time scale, as Tattersall discussed, but one of the misinterpretations of modern biology that I referred to is the idea that changes have to be gradual. That was thought at one time, but now massive evidence that it's not true, which is why Tattersall proposes this without comment, because it would be normal evolution. Evolution is not natural selection, of course. It doesn't have to be just gradual. There's a fair guess that, in fact, it's the only guess I know, that some slight rewiring of the brain yielded merge, roughly in Tattersall's window, say 50 to 100,000 years ago. That provided the basis for unbounded and creative thought, what's sometimes called the Great Leap Forward, that's revealed in the archaeological record right about that period, and the remarkable differences separating modern humans from their predecessors, any of them that we know of, and the rest of the animal kingdom. Well, another comment is that every computational system has to have a collection of elements that are atomic for the purposes of the computation, though like atoms, they can be decomposable by other means. For language, these are what are called the lexicon. They're roughly word-like elements. Though I think there are good reasons to accept the proposals at the origins of generative grammar about 60 years ago, that the notion of word is really a phonological notion, not a syntactic notion. I think so. I won't go into it. Well, whatever these elementary units are, they pose another problem, a very serious and deep problem, for some eventual study of the origin of language, if it's ever possible to undertake it. The problem is, and also for acquisition of language, the problem is that these elementary elements, these atoms, concepts, if you like, are quite different from anything found in animal systems, animal symbolic or communication systems. In the animal systems, it seems to be true that symbols conform to what's sometimes called the referentialist doctrine, namely that a symbol, perhaps an animal cry, is associated with some mind-independent entity. So you have a verb that has a certain cry, that means that the leaves are fluttering or something. It's just one-to-one associated with that. That seems to be universal for animal systems. And the doctrine is typically assumed for language too. All the relevant fields, except the doctrine, almost without exception. But it's just totally untenable. As soon closely at even the simplest words, you find it just doesn't begin to hold. There's just no connection between an internal element, however simple, river, table, any rock, anything you pick up. There's no direct connection between that and some mind-independent entity. Always involves some mental constructions of some complex kind. A lot of study of this in the last 40 years. I think the doctrine, though it's still held almost universally, just can't be accepted. That's another important topic that I'll just mention and put aside. And it's only one that's very poorly understood and insufficiently studied because of the power of the referentialist doctrine. I think it's false, but it's very powerful, so it's found it everywhere. Another topic to be discussed, to be investigated. Well, these remarks, of course, only scratch the surface. What I hope is that they'll illustrate why the answer to the question, what is language, actually matters a lot, and also I hope will illustrate how close attention to this fundamental question can yield conclusions with considerable ramifications for the study of what kind of creatures we are. Thanks.
We have a little over 20 minutes for discussion. I will be aided in this activity by assistants with microphones, and I'll ask you to pose your questions to the microphone. I'll also be aided by my youngster colleague over here doing whose ears are very good, who will help make sure that your questions get through to Professor Chomsky. I will also ask you to follow some ground rules in order to make best use of the time we have. First, I'll ask you to keep your questions to issues raised by his remarks here, rather than to a broader range of topics. I'll also ask you to keep your questions short, because they'll have to be repeated. And finally, I'll ask you to keep your questions rather than statements. I'll do my best to, there are lights up there that are in my eyes, which may make it a little hard for me to keep track, but I'll do my best to distribute questions around the room, but please don't be upset if you're trying very hard and somehow you don't get my attention. Okay, so. Oh yes, right, also because Professor Spaltiche is here to assist. Questions can be in French, but they have to be short and to the point too. But of course we know they will follow the natural logic of thought. Okay, so surprisingly I don't see any hands up. There's a hand. All right, could we have the microphone over here, please?
Is it on? Yes. I would like to know something about the emergence, or how can I say that, internal, I don't know how to formulate that exactly, because it's not reached my consciousness yet. So it has to do with that. You mentioned the fact that, we have internal personal language even before it reaches consciousness. I don't mean articulation, but consciousness itself. And I was wondering whether what precedes that can be considered language, in the sense that you think it is structured, and you think that it corresponds to what